All right, the first video this week I'm going to post is about the quadratic formula. I have the definition here. The quadratic formula is a formula used to solve any quadratic. So you can use this formula to solve any quadratic that you run into. Remember, a quadratic is anything that has x squared in it. So if you have x squared in your problem, and the x squared is the biggest exponent you have, you can use this formula to solve. I've pulled four problems from the con practices that I'm going to do with you right here, right now. So first of all, what we need to do is we need to get it in order so that we have this. We have ax squared plus bx plus c equals 0. So we need the x squared term to be first, we need the bx term to be second, and the constant term, or just the number, to be third. And we also need to have it equal to 0. So if you notice here, we have this 14 instead of equals 0, it says equals 14. So what I can do is I can just subtract 14 on both sides. And so we'll have negative 9x plus 10x squared minus 6 equals 0. So I got the equals 0 part. Now I want to rearrange these terms so that I have x squared, x, and then constant. So the way I would do that is I'd put 10x squared first, minus 9x minus 6 equals 0. And if you notice back here in the formula, we need to know what a is. There's three variables, a, b, and c. That a, b, and c in the formula are these numbers right here, a, b, and c. All right, so it just goes in order. Here's my a, here's my b, and here's my c. What I like to do is I like to come over here and go a equals 10, b equals, make sure you get a negative 9 there, and c is equal to negative 6. And then we're going to plug everything into this formula that we have right here. We're going to take all this and we're going to plug it all into here. All right, so I'm going to bring this formula over here, kind of write it small so that I have it to refer to as I'm plugging these numbers in. The first thing we need to do in the formula is this piece right here, negative b. So we're going to have to go negative for this negative in the formula, and then we also have a negative in the number for negative 9, and then we have plus or minus the square root of, and then I'm going to have b squared. b is negative 9, so negative 9 squared minus 4, that's always just a 4, times a times c. A is 10, c is negative 6, divided by 2 times a. All right, so let's do some calculations here. All right, so down here we have some calculations that we've done. This minus negative 9 is going to turn into a positive 9. If you plug all of this without the square root in your calculator, you should get 321. And then we have 2 times 10, which is 20. Now, one thing we need to do is we need to make sure we check to see if there's any perfect squares inside 321. We've done this before. We're trying to break it up into, well, actually, no. What we did in class is we said, what's the prime factorization for 321? And it's 3 and 107. The only problem, though, is it stops right there. And if you remember in class, we were looking for pairs. And so there are no pairs here, so we're going to keep it 321 over 20, and this would just be my answer. 9 plus or minus the square root of 321 over 20. Let's look at another problem here. The con practices always like to get things out of order and not have it equal to 0. So you're going to have to, on every con practice, you're going to have to be adding stuff, subtracting stuff, and then rearranging things so you have x squared, x, and then constant. For this problem, I'm going to rearrange this already. So we have negative 9x squared. That 3x was positive. I'm going to leave a little space here and I'm going to go plus 10. Now I'm going to add 10 here to both sides. And this is like a plus 0 right there. And so that becomes 0, and I have negative 9x squared plus 3x plus 10 equals 0. I have exactly what I need now in order to start the quadratic formula. I'm going to pull across my a, my b, and my c. So if you write it in order like I have it here, x squared, x constant, the reason we like that is because the letters go in order too. Negative 9, 3, and 10. Okay, so now we can start the quadratic formula. So if you remember, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So for this one here, we're going to start here with this minus b. b is positive 3, so x equals negative 3 plus or minus the square root of b squared. Well, that's just 3 squared minus 4 times a times c, all divided by 2 times negative 9, which is a. Okay, so to do some calculations here, we get negative 3 plus or minus the square root of 369, if you use your calculator there, all divided by negative 18. All right. So again, what we want to do from here is we want to see, is there any perfect squares hiding inside 369? So I gave you a prime factorization sheet when we did this in class, but I'm just going to do the prime factorization here. So this is going to be 3 and 123, and then this is going to be 3 and 41. So the prime factorization of 369 is these three numbers right here. And if you notice, unlike the last problem, we do have a pair of numbers here. Okay, so I'm going to rewrite that. Let's go to this next page. I'm going to rewrite this. Negative 3 plus or minus the square root of, and then we said we would write like this, 3 times 41 all over negative 18. And then so we did have a pair that came out. And remember that when we pulled those out, this is like square rooting 9, because 3 times 3 is 9. So it'd be plus or minus 3 square root 41 over negative 18. And the reason we do that is because sometimes in this little triangle right here of numbers, you have a common factor, or you can divide them all by something. And so I have 3, 3, and 18. Those all can be divided by 3. And if I simplify that, I'll get negative 1 plus or minus the square root of 41, because that 3 turned into a 1. This 3 right here turned into a 1, which I don't necessarily have to write. So I'm just going to leave it out. Plus or minus. And then if I divide the 18 by 3, I'll get negative 6. And so this would be my final answer for that problem. Let's look at another one. Okay, we have another thing that's out of order and not equal to 0. So let's minus the 17x over to here, and then we're going to rearrange it. So I want this to come first, 10x squared. I want this, after I subtract it, to be second, because it's the x term. 8 minus 17 is negative 11. And I want that negative 6 to be last. Now I have exactly what I need. A equals 10, B equals negative 11, and C equals negative 6. So again, I'm going to write my quadratic formula up here. I would recommend just having this somewhere when you're doing these types of problems. Just have it somewhere to refer to, so you know what variables go where, and you don't get yourself all mixed up. So, negative b. When b is negative 11 already, and then you put a negative sign in front of it, it actually turns into a positive 11. So, positive 11 square root of negative 11 squared minus 4 times a times c. Okay. You'll need a calculator for these two to make things go a little quicker. And then for the bottom, we have 2 times a, but a is 10. So we have that right there. So what we have here is 11 plus or minus the square root of, and then 2 times 10 on the bottom is 20. I'm going to pause for a second and do some calculations underneath the square root. All right, so when I multiply everything out underneath and add the stuff underneath the square root, whoops, all of this turns into 361. Now this actually becomes unique because, you may not remember this, but 361 is actually a perfect square. And so we get 11 plus or minus the square root of 361 is 19. Let's go to this next page here. And so since these are all whole numbers, all this whole number, there's no more square roots, I can now simplify this further. So I have 11 plus 19 over 20. And remember, that plus or minus takes on two different forms. And then we get 11 minus 19 over 20. 11 plus 19 is 30 over 20. That reduces to 3 over 2. And 11 minus 19 is negative 8 over 20. That reduces to 2/5, and that's negative. So it is possible to have fractions, okay? And when you plug these into Khan Academy, well, actually, I think in the directions they'll have, they will have these fractions already there for you. You just have to select the right answer with those two in it. But my two answers would be 3/2 and negative 2/5. Okay? And that would be my final answer for that one. All right, last question here. I'm going to minus the 10 over to here, and since there's no like terms on the right side, I'm going to put it over here where there's a blank. That makes 0, and I have negative 4x plus 3x squared minus 10. Now, it doesn't matter if the equal sign's on the left. Don't worry about that. But I still do want to put things in order. So my 3x squared comes first, my minus 4x comes second, my negative 10 comes third. And then I want to write down what a, b, and c are. So a is 3, b is negative 4, and c is negative 10. And again, I'm going to write this down because I want to have it to refer to. So I have negative b. B was already negative, so it's going to become a positive 4. Square root of negative 4 squared minus 4 times a times c. So a is 3, c is negative 10, divided by 2 times 3 is 6. Okay. Now, if I were to simplify underneath the square root, I get 136 over 6. Okay. Just like on the second problem we did, we want to see if 136 it has any perfect squares hiding inside it. And if I do that, I get 2 and 68, and then 2 and 34. So I do have a pair. Excuse me. Let's go to the next page and let's rewrite that out here. So 136 is 2 times 2 times 34 over 6. And as I square root that, only 1 2 comes out. And I get 4 plus or minus 2 over 6. And then notice here again on this little triangle of numbers, they're all divisible by 2. And if I divide them all by 2, I get 2 plus or minus the square root of 34 over 3. And that's my final answer. So I know this video was long, but these problems you'll see on the Khan practices, so I thought it was worthwhile to create a long video. But it's very geared toward your Khan practices. Let me know if you have any questions. Thanks, guys.